we are going to talk about the Java access modifiers primarily. So, what is Java access modifiers, or what are Java access modifiers? Basically, so when we write programs, uh, we create classes and other types which are like the part of object-oriented programming model. So when we create those things, we can control who gets to access which part of that object or the type that we are creating. So that's the kind of access control that is controlled by the Java access modifiers or the access modifiers in general. Basically, so the access modifiers give you the ability as a programmer to define which part of a type is exposed in what way. So that's the idea of Java access modifiers, and we'll just like take a look at what we're going to cover in this topic here. So first things first. First, we are going to look at the package declarations. So what are package declarations? Basically, package declarations are a way of you know grouping the related components together in form of packages. So packages are like your virtual organizational units wherein like you have modules. Multiple modules can belong to same package, or like one package can be spanned across multiple modules, and so on and so forth. It can be other way around as well, like multiple modules, or like one module can have multiple packages, and in this way, like it's just a logical way of separating things. Next topic that we are going to cover today are accessibility modifiers. As I said, accessibility modifiers are a way of telling what is accessible in what areas of your program. Then we are going to talk briefly about static imports and simple imports. So basically, how do you import, and what is the difference between a static import and a simple import? Next topic is the Java programming structure. How do you structure your program? That's the entire goal of the class that we are going to focus on today. So first, let's just understand what are packages, how do you create them, and how do you use them. So to make types easier to find and use, to avoid naming conflicts, and to control access, programmers bundle groups of related types into packages. So what are types? As we said earlier, types are your classes, your interfaces, and other things which we are going to discuss later on during this course. So when you want to combine them or group them into related organizational units, you use packages. So just to bundle like the related items or related types together, you can bundle them inside a single package. A package is a grouping of related types providing access protection and namespace management. Note that types refer to the classes, interfaces, enumerations, and annotation types. Enumerations and annotation types are special kind of classes and interfaces respectively, so types are often referred to in this lesson simply as classes and interfaces. So, as I said, like types are mostly for our general discussion purpose would be classes and interfaces, and packages give you a way of organizing these under specialized namespaces so that you A can avoid naming conflicts, B can also refer to like to items which are only exposed through the package, and not like not expose everything or every type from your program. The types that are part of Java platform are members of various packages that bundle classes by function. So fundamental classes are in java.lang. Classes for reading and writing, which is input and output, are in java.io, and so on. You can put your types in packages too. So I'll show you like what we mean by this. Basically, I'll just show you with an example shortly. But first, let's just go through all the contents of this particular slide and try to understand the basic theoretical part, and then we'll look all of the in action. So, as I said, like the Java language platform, Java language is composed of first your Java runtime, which is the runtime which takes or runs the Java code as a virtual machine or inside a virtual machine. So that's the composition of Java runtime. So Java runtime is a combination of Java virtual machine and the execution engine. And then you have Java compiler, which is like the the program which compiles Java code into Java bytecode. And apart from Java compiler, the next part of JDK is your Java framework library. So Java framework library is a set of predefined classes, and for like certain simple actions like reading and writing from a file, or talking to a network resource, right? And the fundamental classes like string, integer, and so on. So these things are defined or organized in packages in Java framework library itself, and you can do that too in your programs. The types that comprise a package are known as package members. The package statement must be the first line in the source file. So when you create a source file is the program code file, and when you create a source file, the first line, if you are using packages, it should be the package declaration, the first line. To use a public package, members from outside its package, you must do one of the following. A. Refer to the member by its fully qualified name. So either you can refer to the fully qualified name of the member that you are using, or import the package member. And third is basically import the package member's entire package. So you can import the entire package as well. And I'll just go to start. Where's the So we have got this. If you see here, this is the first time that we have got this packages concept. On the chapter 1 and 2, we didn't have any, like this was the default package, we didn't have any package as such. But here we have got a package that we have defined. The first one is like we are organizing all of this under com.janbask.packages, right? So that's the idea of using packages. And I'll just go ahead and close all. Let's close all. Right. So we'll first start with the default. So here we have got our main program or main class. And if you see here, the first statement that we have is the package name of the package that we are declaring. So this particular class, this main class, it belongs to the package com.janbask.program. So this way we have organized all the related types here. See, in this package com.janbask.program, we have got two classes. One is main, the other one is the static imports class. And as we said, the first statement of a program file or a source file should be the declaration of the package, and that is what we are doing here. So we are declaring the package as in the first line of the class. So here, once we have defined, we can import other packages too in our class. So here, if you see, like what we are doing is we are importing everything from com.janbask.packages.star. Dot star means that we are importing all the types from this package. Alternatively, we can import individual packages as well, like import com.janbask.packages.sumCalculator. So if you see here, we are importing this class sumCalculator, and we are also importing the average calculator. So I'll just run this main run as Java application. So here it calculates the sum and it calculates the average. Let's say if I didn't import this, so if I just ignore this importing, what it will say is basically it will say that this computable cannot be resolved to a type. So it's not able to find the type computable. And where is the type computable defined? It's defined here in this computable file, which belongs to Java, com.janbask.packages package. So that's the idea. If I go ahead and import this, it's gonna be fine. So it's going to be again available to us, because now the compiler can find the computable type, because we have told it that I want to import this. Now this gives, like, this explicit declaration of import give us the ability to go ahead and not pollute the namespace. So when you start typing, you don't want to import unnecessary things inside your source file to avoid cluttering your namespace. Cluttering your namespace means that when you write something, most of the IDs today have, what do you call it, uh, intelligence kind of they call it intelligence. What it means is like it gives you hints when you type. So here I'll just demonstrate an example. If I say from for some reason yeah, so for some XYZ reason it's not the intelligence is not working. Maybe I haven't restarted my Mac for a while now, but otherwise, like, you'll just get intelligence right away available out of the box. So as you type, you'll get suggestions from the ID saying that, hey, you can use this and you can use that. So we don't want to pollute our namespace. If we don't do that, like, if I comment out, or I can import the specific types. So if I don't do this, these types are by default imported when I do this import com.janbask.packages.star, because all the types defined in this package are now imported. But if I selectively import, then I get an error saying that the computable is not defined. So what I can do is basically I can also import com.janbask. So like this, as you see here, I'm getting the suggestion com.janbask star dot packages dot iComputable. So now this thing is gone. So I have selectively imported the things that I want to. So let's say if I have got more of these in my package, I can just selectively import what I need, just to avoid like confusion and not being in a position where like I am overwhelmed by the number of classes that are present in the package. So that's the way of importing packages. And that's the way of using packages in general. How do you like this is how you define the packages, and then you import them inside your other source files so that those types are available. It's not just your packages. We can do that with the Java language itself. So like if I want to use the types available in the Java dot import Java dot io, right? So I can do that, and now I can say I can define the types here, or maybe uh, stream. It says stream reader cannot be resolved. Change to stream. So you see, I can see the stream is defined in Java dot stream package. So it's like it's defined in the stream package, and the class name is stream. I can use that, or I can just define I can import all the types in the stream package itself, and say stream dot star, and say stream new stream equals to new strval stream. Although I might not be able to use this type because stream uh, is it's an abstract class, so I cannot create an instance of a stream. What abstract classes are and everything else, we'll just go ahead and read in the or study in the coming chapters when we'll talk more about the object-oriented programming. But for now, like this is the way of importing packages into your source code so that you can use them. All right, so that's packages. Next, apparent hierarchies of packages and ambiguities. At first, packages appear to be hierarchical, but they are not. For example, in our code, we have a com.janbask package and a com.janbask.packages package and a com.janbask.program package. However, the com.janbask.program package and the com.janbask.packages package are not included in the com.janbask package. The prefix com.janbask is used for both to make the relationship evident, but not to show the inclusion. So as what we mean by this statement is that, however, like we just want to show the relationship between the com.janbask.program and the com.janbask.packages. They are not hierarchical. Which what it means is that the com.janbask doesn't include. So if I say com.janbask.star, it doesn't mean that like it's going to import all the things from the package and the program package. It's just to show the relationships, so that like when you are as a programmer look at them and see, okay, yeah, they're related, or maybe they are part of the same module or same system, but they are not hierarchical. Importing com.janbask.star imports all the types from the com.janbask package, but it does not import com.janbask.packages or com.janbask.program packages. If you plan to use the classes and other types in com.janbask.packages as well as those in com.janbask.program, you must import both packages with all their files. So you have to import it using this fully qualified name of the package rather than just doing com.janbask.star. If a member in one package shares its name with a member in another package and both packages are imported, you must refer to each member by its qualified name. So what do you mean by qualified name? So let's say if I have a type defined type like com.janbask. So if I have a package which says like if I want to define another main class here, right? So if I want to define, or let's say I'll just new class, and I'll just call it same class, and it's going to the packages folder. So here, like, it's going to the packages package rather. I'll just finish this. So this is the same class. I can define the same class here as well. New class same this is class. Finish this. So I've got two same classes, one here, and I come to here, and instead of doing like this, right? So I'll just import everything from the packages thing, right? And now if I say same So if you see here, it's picking the same class from the same package that we are referring to. So it's picking it from the com.janbask.program.same class, right? However, because that's this same class is local to this package. However, if I create another thing here, and if I add a new package here, com.janbask.new or duplicate. We'll just call it like just to make it a little bit more trivial. And if I add another class here, I'll say a new class, and I'll call it same class as well, just to confuse it a lot. And if I come to here, and if I say import com.janbask duplicate or store, right? And I delete this same class from here. So it's gone. Now I get an error saying that so basically either I can import it from the duplicate or from the packages, but I cannot I cannot like import both the statements. So let's say if I go with this quick fix, whereas like I want to import it from the duplicate. So now it's more explicitly imported, right? I have imported it more explicitly. There's one way of doing this. I can just do it like this, or the other way is I can use the fully qualified name to define like which same class I'm talking about. So here it's like this, and then I can use it like this to say that okay, this is the same class that I'm interested in. So I can specify the fully qualified name of this thing, which is like a way of telling the compiler to about the area that I'm specifically trying to look into. I don't even need this import statement because I have already specified the fully qualified name here. Okay, so that's now let's talk a little bit about static import. So there are situations where you need frequent access to static final fields or constants and static methods from one or two classes. Prefixing the name of these classes over and over again can result in cluttered code. The static import statement gives you a way to import the constants and static methods that you want to use so that you do not need to prefix the name of their class. Ordinarily, to use these objects from another class, you prefix the class name. You can use the static import statement to import the static members of a class so that you don't need to prefix the class name. Once they have been imported, static members can be used without qualification. Obviously, you can write your own classes that contain constants and static methods that you use frequently and then use the static import statement. And I'll show you shortly, like just right now, what I mean by this. So if I look into this static imports program, I see. So first, we can import individual static members of a type. So let's say this math type, the math class, has got a static constant which is pi. The value of pi is constant, right? So we know what is the value of pi. It's a constant. It's not accurate. It's like a double value which is like closer to pi, and it's like right now basically the most, what do you call it, advanced, or I would not call it advanced, I would say like most accurate or nearest value of pi available out of the box in Java framework for you. And it's like a double precision floating point number. And here I can just import it statically. So what I mean by statically is that I'm importing this value of pi, and as soon as I do that, I can just use the value of pi here. So directly I can use the pi. If I haven't done this, what I would have been required to do is basically I would have been required to write something like this. So I should have accessed it like this. So this is how it would have been written if I wouldn't have like imported that. But if I can also import, another way is to import the math class, just the math class. So what I can do is basically I can just import the math class, not the entire static import thing. I can just import the math class, and I can remove the static keyword from here. And now I can just say math.py as well. So that also works, right? So I can just import the math class and then just define. So instead of having to type math again and again and again, what I can do is I can just have the static import thing going on. And that way, if you see, like I have demonstrated, one is to use the class qualified name, the other one is to use the fully qualified name, and the third one is to use the static import qualified name, which is just the value of the concept. So you can do this in all these three ways. So that's the concept of having this static imports. Now if you look, this math class exposes this pi as a static constant or static constant, right? It's like a constant that's available on it. So if I jump to go to open declaration, if I go to open declaration for this thing, this math class, here is the declaration of math class, right? And if you see here, this is the public static final double pi. So this is a static member on the math class, and this is the value of pi that has been exposed here. So the idea is like here we can just import any static members using the static importer in our classes or in our source files. Access level modifiers determine whether other classes can use a particular field or invoke a particular method. There are two levels of access control. At the top level, public or package, private, no explicit modifier needed. So when you just declare something at the top, which is like the public, you can just say public. Or if you don't specify a access modifier, it's by default package private, which means that it's available only inside that package and not outside that package. So that's the concept of package private. At the member level, you can have public, private, protected, or package private. So for package private, you don't need explicit declaration, but like there are different kind of levels that you can say defined for your members on a specific type. So you can have public access modifier, you can have private. Public is like where the type is available, the members is also available. So that's the public. So if the type is public, the members are also public. So if you say something, if I come to this here, if I just come down here, and so if you see here that the class is public, average calculator, and the method compute result is also public. So this means that because this class is public, this method is also public. So both of these are the combination of accessibility is public. So it's like as soon as you import this package inside any class, both this class and this what do you call it, the method compute result would be available. So that's what it means. I'm trying to show if I have let's see, computable same class. Okay, I'll just use this class to demonstrate an example here. So here, now the other way is like of doing this is void test function. Remember, void doesn't return anything, so I say void test function, and I'll just say system dot out dot print line, and I'll say what do I want to print? I want to print test message. Yeah, right. So this is a simple function. It does nothing fancy. It's just exposing a function called test function. Now this function, that because I have not specified the access modifier for this function, by default this function is package private. What that means by being package private is that I can even like, okay, let's just make it static so that I don't have to create an instance of this. And what I can do here is and come to this one, and I can say same class dot test function. So I can just call this test function from this class. I can do that. But the same thing, if I try to do it from here, which is the main, so main is like this is another, and if I import that package, which is like import com.janbask.packages.same class, so I'm importing the same class. Okay, done. And if I do the same class here, same class, it's able to resolve the same class, but it doesn't have that some function here, right? So it's not, it doesn't have the test function that we created here. See, so it doesn't have the test function. However, if I change this to be a public static void, and if I come back again here, and if I hit the dot, now the test function becomes available because I've changed the access level of this function. I want it to be public, available outside of this package. So the default access level for a function, if you don't, or if for a member, if you don't specify its access level, is package private. The same applies to the class as well. So I can just remove this here, and now if I come here into my main thing, I would not be having access to the same class.
because what happens is my same class now becomes package private. The level of same class is package private. And obviously, like if you look closely, the access of a member is as to the maximum is that of its parent class or object or type. So this test function cannot have more cannot be exposed at a place where the same class is not available. Simple, because it's a member of same class. So even though the function test function is public, because that class in itself is package private, you cannot access it from outside the package. So that's the idea of having the package private. Let's switch it back to public. All right, so that's the idea of the access modifiers and the package private thing and the private. The next one is private. So private is like something which is available only in this particular class. So if I make it private, it will not be available outside of this particular class. So this same class will be like this thing will be available only in this particular same class. It's not going to be available outside the same class. The third one is protected. Okay, let's have to just the next one is protected. Protected is like if you want to define types or like if you want to define objects inside a particular type, you can have protected modifier, which means that all the subclasses of that particular class can have access to them, but not any other class. We'll talk about subclasses and inheritance in the next chapter, maybe fourth. I don't specifically remember. We'll look at the end of the class today, see what's this agenda for the next chapter. But yeah, so basically the protected members are the members which are only available to the subtypes of a particular type. So subtype means a class which inherits from a particular A or B, so like from the parent class. So that's called a subclass. So for example, if you have A class, or just to give you a better example, we have got a person class that defines the characteristics of a person. So, and then in our program we might have a student class which also derives from the parent from the parent person, and we also have a teacher class which is also a subclass of the person, because like there are certain shared characteristics between the student and the teacher, right? So both of them are persons. So we can create a person based class, and then you can use inheritance to pass on the characteristics of the person to student and to the teacher, because both of them are persons, right? So that's the general analogy. So in case of protected members, your protected members are available only to the derived classes. So in our example, if I declare something as a protected member in the person class, that protected member will be available to the student, inside the student and inside the teacher class, but not inside the, let's say, school class, because school class is not derived from the person class. So if I try to use it in any other class which is not derived from the parent class, I cannot do that, and I'll get an error. A class may be declared with modifier public, in which case that class is visible to all classes everywhere. If a class has no modifier, the default, also known as package private, it is visible only within its own package. So it's only visible within its own package. So the class can have two modifiers. One is public, the other one is package private. The next thing, for members, at the members level, you can also use the public modifier or no modifier, which is package private, just as the top level classes, and with some meaning and with the same meaning. For members, there are two additional access modifiers. One is private and the other one is protected. I have explained the private just to define it in formal words. The private modifier specifies that the member can only be accessed in its own class. The protected member Modifier specifies that the member can only be accessed within its own package as with package private, and in addition by a subclass of its class in another package. So if it's like if it can only be accessed inside the package, the same package, and also inside any other class in different package or in the same package, which is an inherited class. So if I want to use, if I say protected, what that means is like in my current package, all the classes can see that member, but outside the package, only those classes which inherit from that particular class can see that. This is a table which gives you a very good idea as to like how you, what are the type of access levels that you have. So there are certain tips or certain rules that can help you in writing better controlled programs which have good access levels, like the access levels meaningful, and most importantly, they don't let you write code which can break or which can violate the security of your program. So to make program secure, or like to avoid people with without like with doing stuff that they are not supposed to do, you just control their access, like what they can access and what they cannot. So uh, there are certain tips. Use the most restrictive access level that makes sense for a particular member. Use private unless you have a good reason not to. So by default, use everything as make everything as private, unless you don't, like you either need to share some of the things across your packages, and only make those members as as uh, package private, which you need to share across the package. Everything else should be private, and only expose those members which you think are part of your API, which will be used by somebody else, as public members, so that like you don't expose your program code or the source code to anybody to just misuse it. Avoid public fields except for constants. So don't create public fields. What do you mean by fields? We'll look into them in more detail when we look at the classes. But by default, fields are the class level variables that you create. So when you create fields, uh, don't make them public. Expose the access to the fields through get and set methods. What get and set are, we'll just look them later on. But right now, it's just a good idea to make this framework inside your brain, saying that okay, everything should be like private by default. Don't make public fields inside the class. So you know it, and then when we in the next classes, when we see those examples in the classes, we creating fields and getters and setters, you'll see, oh yeah, this is something from the previous class, and it makes sense. Right. So more on this when we discuss inheritance concepts in chapter 4 and 5. So here is the Java program structure. We have already seen that, right? So we have this package, we have this hello world class, we have got the static void main, and then the final implementation, or the statements that are to be executed inside the main method, or the main starting of the program. So here we have the package declaration. We have got the public class hello world. This line has like various aspects of Java programming. First, it's public, so this is the access modifier. The class keyword is used to declare a class. The comment section, you can write the comments. As you can see here, you can create comments in two ways. One is this way of creating comments. The other way is like I'll show you here in my ID. I can show you. If you come here, like this is one way of writing comments. The other way is commenting out is basically prefixing it with a double backslash. I don't know, it's backslash, it's forward slash, sorry. Using a double forward slash is another way of commenting out something. So if I just want to write a one-liner comment, what I can do is I can just use a double forward slash, and comments are like literally ignored by compiler. So compiler just thinks that this is the developer ranting about something, and he doesn't care, like the compiler doesn't care as to what is written there. It doesn't even try to perform like some sort of uh, spelling checks. If you see here, this spelling check that you can see here, it's not by the compiler, it's by the spell check that's available inside the Spring tool suite. So this red squiggly that you see here is not done by the compiler, but it's done by the IDE itself. Okay. So we have got this word polymorphism defined here. Uh, Apply. Okay, it's not able to find it. Okay, anyways, like it's not able to find the dictionary file. But we were talking about uh, yeah, the commenting part. So this is how you write comments. So if you see here, we have also used comments here, like something like this, and some. So if the quickest way to like remove a line of code is to comment it out. So if you're writing some code and you're like something is not working, or you want to experiment with stuff and you just want to see whether this thing works, and then you want, after experimenting, you just want to remove that. So the quickest way is to like comment it out, but leaving it there is not a good idea. Comment it out while you are still testing, but as soon as you are done testing, and you're just like okay, satisfied with whatever you want to do, and you have your final piece of code, it's always good to remove the commented out lines, or the code which you have commented out, just to make sure that like just during your experimentation phase, don't use commenting as a way of like removing code, because that becomes a habit, and when that becomes a habit, it like results in a situation. I've seen program files or the source files wherein like there is just 2 lines of code and 200 lines of comments. And how did those comments come in there? Because people, to remove the code, people just kept on commenting, and eventually like the only thing that was required in that little class was 2 lines of code, but nobody removed that extra redundant code that was just there lying as comments. So it looks bad, and obviously it's not maintainable. So just if you do that, remove the code which is not available, or like which is not usable anymore. Okay. So this is a list of Java language keywords. You see, like it's a complete table, and I hope you must be receiving these PowerPoint presentations. So I would say that you just go through this list. It's not required to explain all of these, because we'll explain as and when they are relevant. But it's really good to know that all these keywords, they are they are the Java language keywords. So you cannot name variables. So I cannot call a variable byte, because it's a part of Java language. So these are restricted, so that you cannot be used these keywords as your identifiers. So that's all about the Java language identifiers, the package declarations, and the access modifiers. Now, if you have any questions, we'll talk in a little bit. But in the next session, what we are going to talk about is how does package declaration is relevant in the OOPS context. So how do you look at it from a OOPS perspective? By the way, the OOP stands for Object Oriented Programming. So it's a short form for OOP. And in OOP, what we look is like the classes, the interfaces, the inheritance, polymorphism, uh, types, and so on. So like there are multiple principles of things that we should be like. We have this polymorphism, we have got overloading, overriding, uh, inheritance, encapsulation. So we'll look at all these principles in detail, and then finally we'll just look a little bit more about the accessibility modifier, the import statement in object-oriented context. So how does this all fit together? So that's generally all about our next chapter. Then we're going to talk about Now, for the current class, if you have any questions or if you feel like asking something, you can just go ahead and ask me now. Not just this class, if you want to ask something about the previous classes, some topics that you would have seen and now you want to ask about them. It's a good time to ask.
I'm good. Yeah, I'm good.
All right. So in that case, like we can just close the session for today. And as an assignment, I would for today's class, like I would say that what we can do is basically you can, because we have just discussed about the packages. I would like you guys to list down the possible scenarios. Just list it down. I don't need you to write some code. I just want you to list down all the possible scenarios where you think that your packages, or like the packages that you create, could be helpful, like just the benefits of using packages. So if you want to write some scenarios, you can do that, or if you want to explain and write a good story about it, you can do that as well. There's no problem with that. The idea is like just to understand like how well you have grasped the concept of packages, A, and do you have the understanding to apply it in the practical program? So that's the B. So this is the objective of this exercise. This is the first exercise. The second exercise is, if you can list down all the access modifiers and create a table of like combination of, like, let's say if a class is public and the member is protected, so where what all places it's available, the member and the class. So that way, like, you can see a visualization of the things as to where a particular type or what a particular access modifier does. And that's a really good way of making it natural for yourself, so as like it becomes a natural part of your thinking. If you do it uh, one time and just like look at that, it becomes very intuitive to look at that and see, yeah, it's like, okay, if I have a new type, or if I create a new type, and if I make its member private, obviously it will not be available anywhere. If I make it protected, in what all places it will be available. If I make it package private, what all places will it be available, and so on. So there you can create a kind of a table. So you can say that class and then member, and then you can, on top of it, you can have your one column which says public, the other column says package public, and so on. And then you can just tick that particular thing in across the package. So if you can see, okay, if this thing is going to be available outside the package, then you tick it. If it's not going to be available outside the package, you just create another table where it's the package, class, and yeah, so package and class. So when you say, okay, if a variable, if a class is public, it will be available in the same package, another package, and the same and any other class as well. So you tick all three of them. The same. Next, we look into the package private class. That particular class will be available in the same package, will be available in another class as well, but not in any outside package. So you just can like build that kind of a, what do you call it, a mental map for yourself for the rest of your life if you do this exercise. So that's the second exercise that I would like you guys to do. And basically it will be helpful if you can show me your exercises tomorrow before we start the class. All right. Any questions about these exercises or any doubts? I hope they are clear.
Yes.
Yep, they are.
All right, thank you so much for joining in today. I hope you have a good day today. I'll see you tomorrow. Thank you.
All right. Have a good day, Pradeep.
Bye-bye.
Thank you.